Okay, this is advanced math going over Unit 1 review worksheet. I've done number 7. I am now starting number 11. Okay, so just a reminder that when you're multiplying and or dividing fractions, you always factor before you reduce. You can't reduce individual little pieces because of all the plus and minus signs. And you do whatever kind of factoring each problem requires. Okay, what kind of factoring does this one here require? GCF, good. Of 2, and then you have x plus y. How about the denominator? Also GCF, 3, and then x minus 9y. I'm going to pause here. Did you do any of this part yet on your own?
Yeah, I factored out everything.
Okay. Okay, so you did this part, and then you left this as x minus y.
Yeah.
And changed that to multiplication?
Yeah.
And you flipped that to the top, right?
Mm-hmm.
9y minus x. And how did you factor this piece here? What did you factor it to?
I took out 28x.
28. Okay, it's just a 28 because they do not both have an x. And do you see that? So you're left behind with an x squared minus y squared. That could be where the mistake was made. Yeah? Okay. All right, and now I see that I can still factor this. Do you want to factor it now or just reduce what you can and then factor in the next step? It's up to you.
We can just factor it now.
Okay. Some kids will just erase it and factor it there, but I wrote on pen, so I'm just going to do it on the next step. 2 x plus y. Okay, and then 28 parentheses x plus y, x minus y. All right. And then what can we reduce?
I crossed out the x plus y next to the 2 on top.
That one and that one?
Yeah.
And just make a note, I can't cross out those two because they're horizontal, right?
Yeah.
And I'm going to put parentheses here. Okay, anything else?
I know you can do with the x minus 9y and 9y minus x. It's like a lot of negatives.
Good. So if I cross them out and pull out a negative, I just put it out to the front.
And then I crossed out the
3's.
and then the 7 and 28.
7 becomes 1 and 28 becomes,
4.
and anything else?
That's all I've got.
Okay, so I have negative 2 times 1, and that's a 1, so negative 2. That parentheses gone, that one's still there, x plus y, and that one's gone. Gone, x minus y, 4x minus y. So 4x minus y squared. Now that I have it all together, can you see that there's still one little thing that I can reduce? Some numbers.
Yeah, the 2 and the 4.
Good. I can still reduce the 2 and the 4. So this is 1, this is 2. So negative parentheses x plus y over parentheses x minus y quantity squared. I can't reduce the x's or the y's. That there is your final answer. I did mess up on one little piece. Tell me what it is. I'm transferring this to this.
You mean the x minus y
I can't reduce them because that's a plus, that's a minus. It's something like I have it right over here, I just didn't transfer it correctly over here. The 2. I lost it in my transfer. It's transferring over. Okay, make sense? All right, number 12. 12 is kind of like a higher level thinking problem. I haven't gone over one specifically like that. It just requires you to do some higher level thinking. Do you need this one up still?
No.
Okay. First off, can you see that it's going to be a common denominator problem? If you wanted to, you could do common denominator is a minus b, b minus a, multiply by what's missing, distribute, and blah, 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 and it's going to be a really long problem. Or recognize that these two are called what? Starts with an O. Opposite. So I'm going to take, it doesn't matter which one, I'm going to take the negative one out of that second one, and I'll show you why in just a little bit. So I'm going to leave this one as 1 over a minus b. And the second one, 1 over, and if I take a negative out, that negative a is going to become positive, so I'm just going to move it to the front. That positive b is going to become negative, so I'm going to move it to the end. And what do I do with that negative 1 I factored out? I put it right in the middle. So if it's already a minus sign and I took out a negative, what's going to happen to that minus sign? It's going to become a plus. And now they already have a common denominator, so I don't have to do any kind of multiplying. I'm just going to add. 1 plus 1 is 2 over, they're already common, a minus b. Do you see how it ends up being really easy? It's just knowing that one step. And I've never shown that to you before, so that's why it was a little tricky. So it's one of those like extra challenge type problems. Questions on 12? Good. Okay. Number 14. Tell me what your thought process was on 14.
I tried to multiply everything.
Okay, did you make these ones first? I mean,
Yeah.
fractions? Okay. And then what did you multiply everything by?
X squared.
Okay. And tell me what you got. Let me just write it all down first. All right, I'm ready. What did you get?
So I got x to the 3rd power plus 1 over x to the I put x to the 3rd, literally x to the 4th.
Good. Okay, so you caught it right now. You said you thought you wrote x to the 3rd when you did it originally, but now you just caught that it's x to the 4th. Okay, keep going.
Plus x.
Plus x. All right. What would you do next? Oh, let me ask you first. Can I reduce the x cubed and the x to the 4th? No, plus signs in between I cannot reduce. What would you do next?
The x3 plus 1 is that like so?
Good. This here is the SOAP factoring, the cube factoring. Now, what kind of factoring is the denominator? Okay, so what I tell the students in class is kind of play it forward a little bit in your head, at least the denominator. GCF it in your head or on paper, either one, and see what you would get. I'm going to do it on paper. X cubed, do you agree you get x cubed plus 1? With that being said, would you waste your time doing cube factoring in the numerator? You can, and then cube factor there, but what's going to end up happening with all of it anyway? It's all going to reduce anyway, so you're left with 1 over x. So yes, it would cube factor, and yes, that would cube factor, but it would all reduce 1 over x. So it's okay if you did it. It's just if you could play it forward in your head and be like, oh, I'm not going to waste my time because it's going to all reduce. Make sense?
Yeah.
Okay, number 15. All right, so 15's kind of like that one that you asked me about, not the one you asked me about earlier, but the one I asked you to show me when I said, tell me how you did this one. So tell me how you would start this one.
I did 1 over x plus 1 over y all over 1 over x squared.
Okay, and then what did you do next?
That's all I got.
Okay, so do you remember what you did on the previous? Let's see if I still have it. It was this one here. You did 1 over c squared, 1 over d squared, 1 over c, 1 over d, and then this is the one you told me. You told me to multiply everything by c squared, d squared. Same type of problem. What would you multiply everything by?
X and
xy. Very close. xy, but because this is a squared, it would have to be x squared y. That's it. All right, go ahead and reduce it for me. Tell me what you would get.
I got x y squared plus x squared y all over y squared.
Okay, hold on. So right here, okay, what did you use as your common denominator? X squared y?
Yeah.
Okay, so one set of x's reduced, and you're left with, you said xy squared or just xy?
Oh, I meant x y. Oh, I did y squared on everything.
Oh, it's okay. So on this one, what would you be left with?
It would just be x y plus x squared y. It was just x squared.
Just x squared, and then,
Over y.
good. And then GCF the top.
X and the parentheses y plus x.
Does that allow me to reduce? So then this answer would be okay. Either one's fine because factoring does not allow me to reduce. I'm going to go ahead and continue recording for 16, 17, 18, 19. I'll upload it and then post it in Google Classroom, and then you can watch it later.
Okay.
Okay.
Yeah, thank you.
You're welcome. And you'll be back in on Monday, and you
Yeah.
can take it then? Okay. I'm just going to pause for a second, and then I'll come back to it. How fun at your game today?
Thank you.
You going to be cheering for yourself?
Yeah. Yeah. Have a good weekend.
Thank you, you too. All right, number 16. X to the negative 2 plus x to the negative 1 all over x to the negative 1. Very similar to the one we just did. You rewrite it as 1 over x squared plus 1 over x all over 1 over x. And just a reminder that because this is a plus sign, you cannot reduce there or there. You might say, oh, well, I could just reduce because they're both x to the negative 1s, or they're both 1 over x's. Cannot because of the addition sign. So I'm going to go ahead and multiply everything by and x squared. I'm going to go ahead and multiply everything by x squared to clear. All right, x squared reduces completely, leaving behind a 1. One set of x's reduced, leaving behind an x. One set of x's reduced, leaving behind an x. And I cannot reduce just an x because there is a plus sign in the numerator. You don't need parentheses here, it's not necessary, but if it helps, put them in to remind you that you cannot reduce. Okay, number 17. Two x over x minus 3 plus 4 over x minus 2. Now, remember what I've said in class and in notes, make everything a fraction. Now, kids will often forget to make this a fraction and say their common denominator is x minus 3 times x minus 2, and that is incorrect. That's incorrect because x minus 2 is supposed to be x minus 2 over 1. 1 is the denominator, x minus 2 is the numerator of that fraction. So x minus 3 is a denominator, 1's a denominator, 1's a denominator. So your only common denominator is x minus 3. All right, I can see on the first one the x minus 3 reduces completely, leaving behind a 2x plus 4 parentheses x minus 3 all over x minus 2, x minus 3. If I wanted to, could I reduce those x minus 3's? No, I cannot because of that plus sign there. So I have to ask myself, can I factor up here? Well, there's no GCF, but I can distribute, combine like terms, and see if there's anything else I can do. Okay, 2x plus 4x minus 12, and I do have like terms to combine there. That gives me 6x minus 12 over x minus 2, x minus 3, and I do have a GCF. And I do have to factor because factoring might allow me to reduce. I factor out a 6, x minus 2 over x minus 2 and x minus 3. And it looks like I can reduce the x minus 2's, which gives me this. I cannot reduce the 3's and the 6's because of the minus sign in the denominator. So again, you don't need parentheses here, but if it helps you put them in to remind you that is a polynomial, specifically a binomial in this case, and you cannot reduce bits and pieces. Okay, next one. M squared plus n squared all over n minus 2m 1 over n. Okay, as I stated before, make everything a fraction. There we go. Our common denominator is mn, and I'm going to multiply everything by mn. mn. Okay. N's reduce. I'm left with m parentheses m squared plus n squared minus, nothing reduces, and that's okay because I have only 1's in the denominator. As long as my denominator is reduced, and if there's only 1's left, that's fine. 2m squared n. Denominator reduces, leaving behind 1 times n, which is n. N's reduced, leaving behind 1 times m, which is m. Can I reduce? No, I cannot because of the minus sign there, the minus sign there. There's nothing I can do here. I can't factor, I can't combine like terms, so that pretty much is done. But in the numerator, I can't factor anything, but I can distribute to see if there's any, I can combine like terms and then factor and reduce. Okay, that's going to be m to the third plus m n squared minus 2m squared n all over n minus m. Okay, now at this point it doesn't look like I can combine like terms, but I do have a GCF. I can factor out an m. Leaving behind m squared plus n squared minus 2 m n over n minus m. All right, I'm going to put a star right at this point and tell you that this is another one of those higher level thinking problems. Those ones where you always have to ask yourself, can I still factor? What can I do? Can I still factor? First off, I cannot reduce yet because nothing reduces. And here there's no like terms, but can I factor? We've talked a few times since we started the review about rearranging. We only talked about it maybe once or twice when we actually did the lessons, but we talked about higher level thinking and rearranging. So m squared minus 2mn plus n squared over n minus m. All right, m double bubble m, and that's n squared, so it has to be n and n. Same sign, neighbor tells me they're both negative. Negative mn, negative mn gives me the negative 2mn, so it works. I look, it doesn't matter which two you pick because they're all three going to match, but I'm going to pick these two. These two are opposites, m minus n and n minus m. They're opposites. So remember, how do I know they're opposites? They're flipped on a negative sign. When I reduce opposites, negative kicks out to the front. Negative m minus n. Now you would not see something this difficult on the test, on the quiz, and if you did on the test, it would most likely be like an extra challenge type of question. All right, I believe that is all of them. Let me double check. Nope, I still have another. Yes, I have number 19 to do as well. Okay, number 19. Parentheses, 3x close parentheses, negative 2, plus 3x to the negative 2. And remember, we have talked about parentheses in notes and in class. If it's in parentheses, the whole thing moves to the denominator. And here, the 3 stays. Now, I did purposely write this part incorrectly because a lot of kids mess it up and they write it like this. They move this down, just the x squared. That's correct. They move this down. Yes, it moves down 3x squared, but the parentheses, because the parentheses are there to begin with, it's still there because you're not only squaring just the x, you're still squaring the 3. So it's not 3x squared, it's 3x times 3x, which is 9x squared. There is a difference. If you wrote it as just 3x squared, you're going to get it marked wrong. Okay, so this is not a complex fraction. Do not treat it as a complex fraction. This is the one where you're looking, yes, you look for a common denominator, but you do not multiply everything by the same thing and clear out your denominators. You multiply only by what's missing. This one's not missing anything. This one's missing a 9. So then I have 1 times 1 is 1, 1 times 9x x squared is the 9x squared I'm looking for in the denominator, plus 3 times 9 is 27. X squared times 9 is the 9x squared I'm looking for, and I end up with 28 over 9x squared, and nothing reduces. That is as far as I can go. All right, I hope that helps.